We are now ready to define a fraction class. Fraction class is available to you in Dropbox as well as in Blackboard. Okay, have a look at the file. Okay, now we want to develop a fraction class which is immutable. Immutable means we should not be able to change the instance variables. Okay, so the user should not be able to change these. So anyhow, let's see what our internal representation of a fraction consists of two numbers, a numerator and a denominator. We wish to ensure that all fractions are reduced to the lowest terms and stored with a non-negative denominator. You see, now you can go to your shell 3/4, right? In Python, if you type in 3/4, it gives you precise answer 0.75. If you instead type in 4/3, it will give you 1.333. It's actually 1.3 repeated infinitely many times, right? So this is an approximation. So you lose some of the information here. What if I want a class where 4/3 is remembered as 4/3? It is not converted to a decimal. Likewise, 3/4 is remembered as 3/4, is not converted to a float. Okay, that's what we would like to develop. So, a fraction consists of two numbers, a numerator and denominator. Now, understand this carefully. We wish to ensure that all fractions are reduced to lowest terms and stored with non-negative denominator. What does that mean? So let me explain using this math editor. All right. So I want to ensure that fractions are reduced to lowest terms. So you have, say you have designed this fraction class. Now a user comes around and the user writes in 16/24. Automatically your fraction class should reduce this to 2/3. Yeah, 8 is common. In other words, it should be able to reduce your fraction, whatever the user gave it, to its lowest forms. Moreover, something like 16/0, it should be given to be undefined. You understand? Now, what else? What if you have a negative denominator, right? 4/-5. What does this even mean? This is a fraction 4/-5. Now, when you look at it this way, now you know what this is. This is a negative fraction 4/5. You see? So this initial fraction that the user gave the denominator to be negative. So maybe we can easily replace it by the fraction -4/5. So this fraction is same as this fraction. All right. So if the user gives you this, your class should be able to write it this. I mean, simply because this is what we are used to seeing. We don't typically write negative in the denominator. It's a matter of taste. That's about it. All right. So you don't want a negative denominator. You don't want denominator of 0. So we will use special methods in this case. Okay. Now here is special methods. Moreover, 16/9 should be represented 16/9. Fraction of 3 should be represented as 3/1. And fraction nothing should give you 0. That is, nothing means default setting fraction is 0. 0 being 0/1 in our minds, right? So we will need to import GCD. Okay. From the file GCD, So make sure when you play with this, you have the GCD file in the same folder where fraction is. That way when you compile it, the compiler will look for gcd.py in the same folder that you are working with and be able to find the function GCD. All right. Okay. So from GCD, import GCD. All right. Now what does this say? The instantiator, it has a self, a numerator, and a denominator. These are the ingredients to make a fraction. By default setting, you see, if you don't give a numerator or denominator, the default should be numerator 0, denominator 1. That is the default. Now, what happens if the user gives denominator to be 0? So, mind you, this is double equal. If denominator double equal is 0, so that is a Boolean value. If the denominator is 0, immediately assign numerator to 0, denominator to be 0, and this is what we call it to be undefined. If denominator is not 0, that's when else takes over. Get the GCD of the numerator and denominator. Notice we have to take absolute value. All right. Why absolute value? Because you could have been negative, positive. Make sure they are both positive, then take GCD. All right. Now, consider the factor, take it away. Keep that in mind. If the denominator is negative, then change the factor to negative of it. All right. Now, numerator is the given numerator over factor. Notice this is integer division. So the result is going to be integer. And the denominator should be the given denominator over the factor. So this is what gets us this situation. You took the GCD out and you stored your factor with numerator 2, denominator 3, even though the user gave 16 and 24 respectively. So self.numerator, self.denominator, that's the numerator and denominator that your object will remember. Numerator and denominator, that's given by the user. Okay. Self.numerator, self.denominator is the numerator and denominator of the object. All right. Now start adding fractions. How do you add fractions? Well, what do we do to have fraction 2 over 3 plus fraction 4 over 5? This all of us know. What do? We look for if the fraction with the denominator being least common multiple. Why would I worry about least common multiple? Let me simply multiply these two. 15. So this guy is missing 5. So 10 plus this guy is missing 3, 12. Right? So that's my addition. Now whatever I get, I reduce it later. Okay. So first I simply take, what is the denominator? Denominator is the product of the two denominators. So I'm going to construct a fraction object, denominator being the first guy's denominator times second guy's denominator. The numerator is first guy's numerator times second guy's denominator plus first guy's denominator times second guy's numerator. That's what this is. Okay, self being first guy, other being second guy. So these, notice other is a fraction object. So other has its denominator and numerator. My answer is going to be a fraction object. So notice this is probably the first time we are seeing a return of an object from the same class. So you're using the same constructor, fraction. Okay. Likewise, subtraction. How do you subtract? Well, if I have to subtract, I just have to subtract here. Okay, so that's all. It's everything else is the same. How do I multiply one fraction with the other? Well, that's easier, right? Multiply the numerators, multiply the denominators. Okay,